will do. Okay, so guys, we're going to get started, and we are quickly. So remember on Monday, we were chatting about fractions and the different size denominators. And we had some people who were a little bit confused about what's bigger. Fraction is a half bigger than a 20th. Okay, so I thought what I'd do, instead of having pieces of paper and things that we ripped up, if we look at a fraction wall, okay, so this is what we call a fraction wall, we can see that. Hello, can you mute, please, my love?
Yes, ma'am.
Thank you. So we can see that this is the size of a whole, right? So if this is a whole pizza here, it's a rectangular pizza, or a whole chocolate over here, if we split it into two pieces, then this was the size of a half. So this piece here would be a half, okay? Or this piece would be a half, okay? And then if we cut it in, so our denominator is 2 and the half is quite a big piece, okay? But if we had to chop it into fifths, look how small 1/5 is. 1/5 is tiny, tiny, tiny. Okay, so when we're comparing fractions, I know some of you are going to know this like really well, but when we're comparing fractions, the bigger the denominator is. So the bigger the denominator is, the smaller the piece of pizza you're getting. Okay, so always think about a fraction wall. The more pieces you have to cut your fraction into, or cut your whole into, the smaller the pieces are going to be. Okay, so if you get the whole cake, then you get a lot of cake. If you get half a cake, that's still quite a lot of cake. But if you only get 1/10 of a cake, you're not getting very much cake. Okay, so fractions, the smaller the denominator, the bigger your piece of paper, or the bigger your piece of cake, the bigger your fraction. Okay, so I just wanted to clear that up before we got started with today's stuff. Okay, because that's quite an important concept. All right. So can we just remember, everyone, that we're going to keep muted? So remember our rules. We're going to keep muted. And if I ask you a question, then you can unmute and you can answer the question. If you have a question, you raise your hand in using the Zoom raise hands. And if I ask a question and you don't get to answer it, then you can write your answer in the chat. Okay, because then that means that you can help somebody else who might be a bit stuck, who's answering a question. All right, and the chat's there for us to have chats in and talk about fractions and maths and cool stuff like that. All right, Princess, your hand is up. What's up?
Ma'am, I was saying that, let's say you have a question and then you answer it, but you get the answer wrong.
That's okay. That's all right if you get the answer wrong. That's what we call, so the best thing, you know what scientists and mathematicians do for their entire lives?
Yes, ma'am.
They get stuff wrong. Did you know that?
No.
If you are a mathematician, then that means that you're probably trying to solve some like really, really, really difficult maths. And you try it one way and it doesn't work. And then you try it another way and it doesn't work. And you try it another way and it doesn't work. And you try it another way. And sometimes some mathematicians and scientists go their whole lives and they never get to the answer, which is quite depressing. But that happens. And so with maths, we keep on trying even if we get it wrong, because it means we've learned how not to do it. So that's good. Okay, so I love it when we make mistakes because it helps us know how we're learning. Okay, so never, ever, ever worry about making mistakes. I make mistakes all the time. Okay, even in my classroom, my kids are always telling me, oh, Ma'am, you wrote that one wrong. And then I have to fix it quickly. Okay, so we're all human. Okay, so let's have a quick look. Are we all okay with the idea of... Are we all okay with the idea of the smaller the denominator, the bigger the fraction? Okay, I'm gonna get some thumbs up or all okay, or in the chat. Excellent. Okay, because that's an important one to know. So we're gonna have a look at doing some more converting. Okay. Wrong one. Okay. So we had a quiz at the last lesson about converting a mix, or first of all, tell me this kind of fraction is called a mixed number because it's got a whole number and a fraction. And we had a look at converting that into an improper fraction where the numerator is bigger than the denominator. Okay. And I found this thing, which is quite cool. It's called the MAD method, right? So you multiply. So first you multiply, then you add, and then you write it on top of your denominator. Okay, so it's the MAD method of improper fractions. All right, so we're going to multiply. So the two numbers that we're going to multiply. Nima, what are we multiplying?
Our denominator of a fraction by the whole.
Good. Okay, so we're going to multiply. Let's find my yellow highlighter. The denominator times by my whole. Okay, so we multiply my denominator times by my whole number. And 5 times 3 gives me 15. Okay. Then let's see who else I can see. I can't see too many people on my screen at a time. Lesedi, what's our next step? So now we've multiplied. Now what do we need to do?
Ma'am, after multiply, you have to go to 5 and plus it by 2, and you'll get 7.
Okay, so remember we've used the 5 with our multiplying, and we've got 15. Okay.
Yes.
So you're right, we're going to add 2, but we're going to add 2 to this 15, the 5 times 3. Okay. So we're going to add this 2. So this 2 we're going to add on. Okay, so we're going to add the numerator 2, which is going to give us how much altogether, Lesedi?
17 over 3.
It's going to give us 17 over 3. Perfect. Okay, so first, our first step is we multiply our denominator times the whole number. So denominator times whole number. Second step, we add the numerator. So that's step 2. And step 3, we write our new number over the denominator. Okay, Kwanda, can I get a smile and a thumbs up if that's cool? There we go. Okay, Kwanda's smiling. All right. So what I would like you to do for me quickly, on your piece of paper, with, oh, they're 2 Lesedis. Okay. I didn't realize there's 2 Lesedis. Sorry. I'm going to have to call you Lesedi M and I'll find the other Lesedi. All right. So Naomi, you're going to follow the steps. Okay. You're going to multiply the denominator by the whole number. Okay. So 3 times 5 gives us 15. That's our 15 there. Then we add the numerator, which is our 2. And that is going to give us 15 plus 2, 17, which is going to go over the denominator. Okay, so what I want you to do is try these ones. Use the MAD step. Okay, so everyone try, even if you don't understand, I want you to try the first one. Okay, use the steps. Okay, so try the steps, give it a shot. And let's see how you go. So remember, we're going to do MAD, which means that first we're going to multiply those 2. Then we're going to add this one, and we're going to write it over the denominator. Okay, so follow the picture. Follow the steps that we followed with 5 2/3. Okay, everybody just do the first one for me. So everyone do the first one and then we'll have a look at them. Oh, some people are flying this evening. Okay, so let's have a look at the first one. Okay, I'm going to try the first one. Tara, what's my first step, my darling?
You have to times 3 by 5
Which
and
is
then
going
say, which is 15 plus 1 is 16. And your answer
And
is 16 over 3.
16 over 3. Well done. Did everyone manage to get that? Yay. That's awesome. You can give me a thumbs up in the chat if you got it, or a thumbs up on the Zoom. Woohoo! Check it, everyone. Okay, so we're going to try. So I see a couple of thumbs down. That's awesome. We're still learning. That's great. And we're going to keep on trying. So now we're going to try the next one. Okay, we're going to try the next one. And remember, we are going to multiply my denominator, my bottom number, by my whole number. So we're going to times those two together. Then we're going to add the 1. And we write it over the denominator. Okay, so Zara, I'm going to get you to talk me through what to do. Okay, Zara. Okay. Zara, can you help me out?
So ma'am has to add times 2 times 8, which is 16. 16 plus 1 is 17. So 17 over 8.
Beautiful. Well done. Nailed it. Good job. Thank you very much, Zara. Okay, Claudie, I'm going to get you to do the next one for me. You're going to talk me through it. Okay. Right. So Claudie, tell me what I'm going to do first.
What I think you're about to do is to say 4 multiplied by 3,
Mm-hmm.
and then 4 multiplied by 3 is 12. Then you say 12 plus 1.
Which is?
Which is 13. And then my final answer will be 13 over 4.
Perfect. Nailed it. Well done. Good job. Okay, Maria, you're up next.
Ma'am, you multiply 9 by 3, which is 27, plus 2, which is 29. And the final answer is 29 over 9.
29 over 9. Sorry, that 9 looks a little bit like a 4. Well done. 29 over 9. Hey, you guys are getting this really well done. Okay, and Jolly, you are next.
Yes, finally.
Love it. Okay,
5 times 6, which is 30, plus 3 is 33 over 5. That's your final answer.
Beautiful. Well done. Everyone,
We never doubted you, Jolie. We always
not
knew
a
you were going to get it
second.
right. We knew you were going to get
Exactly.
it right.
Well done, guys. I'm very, very, very happy. Okay, so it seems like we are getting these right. Okay, so we are going to go the other way now. Okay, we're going to go the other way. So tell me, what is the inverse of times? The inverse. Inverse means opposite. What's
Division.
the inverse? Division.
Division.
Awesome. So if we have to times to go this way, then to go from an improper fraction to a mixed number means we're going to have to divide. Okay, so let's have a look at the step by step. Right. Hope you can't see my examples that I want you to do later. No, you can't. Excellent. Okay, so if we have the fraction, the improper fractions, remember improper means the numerator is bigger than the denominator. So here we can see, here's our numerator. Oh, that's made it very dark. Let's erase that. Oh no, it's not erasing. There we go. Let's use yellow. That's better. There, our numerator is bigger than our denominator, right? That makes it improper, okay? Because he's a bit rude. Okay, he's top heavy. He's going to fall over. All right. So what that means is that we have got 13 out of 6 pieces of chocolate. So here I've got one piece of chocolate, one chocolate cake, and I've cut it into 6 slices. There's 1 slice, 2 slices, 3 slices, 4 slices, 5 slices, 6 slices. And then because I need more cake, because I've still got more slices to hand out, I'm going to have a second cake. And I'm going to have, there's my 7th slice, 8th slice, 9th slice, 10th slice, 11th slice, and 12th slice. Now, do I have enough slices yet? No, and I've run out of cake. So I'm going to have to go to Checkers and I'm going to have to buy a 3rd cake. Okay, and I'm going to use 1 slice out of that cake. And that's going to give me 13 slices. Okay, because remember, my denominator tells me how many slices there are in my whole. Okay, so now if we have to divide, what are we going to divide by? What are we dividing? Who can tell me? What did I divide? Ingrid. Ingrid, can you tell me, what am I dividing? Ingrid's gone away. Ingrid's hiding from me.
You divide by 6.
You say you're dividing it by 6, so you're saying 13 divided by 6. And how many times, we should know this because it's a multiples, how many times can 6 go into 13? It can go
2.
in 2 whole times. Yes. And what's left over?
1.
1 piece. Okay, because 6 times 2 is 12. And so I've got 1 left over. And so my mixed number then is 2 and 1 6. So I've got 2 whole cakes. So if we look here, I've got 2 whole cakes. There's 1 cake. There's my second cake. And then I've got 1/6 of a cake over here. Okay. So before I ask if you understand, I am going to ask you to do a couple for me to try them out. Okay. So let's go up and let's drag. I'm going to leave the example one there so you can see it. So remember, we're going to divide. So we're going to say numerator divided by denominator. So numerator divided by denominator. So 22 divided by 3. And this is where the times tables are so important. Where your teachers go, learn your times tables. Must learn your times tables.
That's me, ma'am. I'm that teacher.
Yeah. I'm that teacher too. All the time. You must know your times tables.
Ma'am, I think Anaki wants to do number 1 for us.
Ooh.
Yeah, if that's okay with you, ma'am.
Yes. Okay. All right. Number 1. Who was it? Who's doing number 1? Ananzi.
Anati.
Anati. Sorry, Anati. Talk to us about number 1.
22 divided by 3 is 7.
Yeah.
Then there is 1 left, so that would be the numerator. So the answer is 7 and 1/3.
And 1/3. Beautiful. Absolutely beautiful. Well done. Okay. Naomi, I'm going to pick on you next. Right? And then Sume, you can try number 3. Right. So Naomi, talk to me about what I need. No, come, you're going to give it a try. I'll walk you through it. Okay. So Naomi, we're going to say 5 divided by 2. Okay, Naomi, we can do this. Okay. Do you want to tell me in the chat, what's 5 divided by 2, Naomi? How many times can 2 go into 5?
Not sure, ma'am.
Okay, so if I got 5, how many groups of 2 can I make in my 5?
4.
So there's one group of 2, and there's another group of 2. So how many groups did I make altogether?
4.
I made 2 groups to get to 4. Okay, so 2 times 2 is 4. So I've made 2 groups, right? And what's left over that didn't make it into my group?
1.
1. And so I've got 1 over 2 left over. And that's it. You just did it. You just did it. That's it. You got it. Well done. Yeah. So did I say? Okay. So just mute again, guys. Got some. There we go. Right. Who did I say was going to try number 3?
Sume is next.
Sume, I said number 3.
Yes.
Right. Sume, talk to me.
Hi, ma'am.
Hello. Okay.
So 21, so I asked myself, how many times can 21 go into 6? And I thought that it's once. No, how many times can 6 go into 21? And it was 3 times.
It was 3 times. You are correct for that.
And then there was the 3 that was remained. So it was 3 and 3 over 6, which is 3 and 1/2.
Which is 3.5. Well done. Okay, 3.5. Excellent. Okay, I'm going to leave it at 3 and 3 over 6 so for now. But that is absolutely perfect. Well done. Thank you, Sume. Okay.
Thank you, ma'am.
Makati, you're going to do number 4. You're going to do D for us?
Yes, ma'am.
Okay, let's hear it.
10 divided by 34. 10 goes into 34 3 times, and there's 4 remainders left. So that is 4 over 10.
Good. 3 4/10. Excellent. Well done. Hey, that was so cool. All right, and let's see if I can make my screen a bit smaller so you can see E. Here is E for everyone to try. And let's see how quickly you can get it. Funny marks, get set, go.
Ma'am.
Yes.
While the kids are doing the last one, and I know they're going to finish like in 3 seconds. I think Nicolene might have a question. Oh, and she's just locked her mic. Oh my goodness. Nicolene, are you there? Oh, okay. I hope she can. If you can't speak, then maybe write in the chat for us. Because I think you had a question that you really, really wanted to ask, and we'd like you to ask it.
Okay. So Nicolene,
and for the record, I knew you guys were going to be done really quickly. I had no doubts.
You guys are far too fast. Way faster than I thought you'd be. Okay. Let's see who I am going to. I was going to ask them. Yeah. My finger's pulling everyone. You guys are replying too fast. I can't keep up. Who was the first person finished? Tanweer. Okay. Tanweer said he was finished first. Right, Tanweer, let's go. Let's hear it. Naomi, my class is not this fast. Sometimes they are, depending on what time of day it is. If it's a Tuesday at 12 o'clock, then they're not very fast. Okay. Okay, no worries, Tanweer, that's fine. Okay, Nima, you said 4 went into 31 7 times, which gives us 28. And we had 3/4 left. Okay, so 7 3/4. Princess, what's your question, my love?
Ma'am, I was saying with the mixed fractions, if you get the if you get your answer, don't we make it smaller?
If you can simplify, then yes, then you simplify if you know how to. Okay.
Okay.
But a good rule is in maths, whenever you can simplify, simplify. But what I always tell my kids to do is, say, for instance, this one with 3 and 3, 6. Then I'd say write 3 and 3, 6, and then an equals, and then you simplify next to it. So that if you make a mistake with the simplification of it, then your teacher can still give you a half a mark for getting that part right, even though you might have made a mistake with the rest. Okay. But I'm not simplifying right just yet because not everyone's ready to simplify. But we did. You are right. This was 3 and 2/5. Okay. So yes, Sume, I do teach grade 7. I do, and I love it. It's my favorite grade I've ever taught. Absolutely love grade 7. I taught grade 4 before. Sure, they're very young. They're very slow. Very, very, very slow. Grade 7's a lot more fun. Okay.
In our school, we actually not doing this.
Oh, you're not doing this yet? You know what? In my school, we're not doing fractions yet either. We're doing exponents at the moment. But fractions is a nice one to go to for now. Okay. So are we feeling kind of okay with turning improper fractions to mixed numbers and mixed numbers to improper fractions?
Guys, can we get like thumbs up, thumbs down? Meh. How are we feeling? Yeah. Oh,
yes-ish.
Yes.
Okay, yes-ish. That's cool. That's good.
Fair. What do you guys
think? Better than not.
Give us emojis. Let us know how you guys are doing.
This is a grade 7 class,
this
yes.
This is a grade 7 class, Angel, yes.
Okay, that's a thumbs up. We had a thumbs up and a thumbs down, so that's cool. Okay, if you're not doing this at school yet, then you'll get there later on this term, probably. Okay.
And think about it, guys. If you guys haven't done it yet, then you guys have like a whole section that you already know. So you can go show off in class, be like, yep, I already know how to do this. Let me step aside, everyone. I will show you how it's done. So you'll be really like just ahead of everybody else.
Okay, awesome. All right. So we're going to practice more of these. We'll do these. So don't stress if you can't get them all, if you're not 100% sure how to do it now, because we're going to keep on as we do things. We're going to practice them. These all build onto each other. Okay. So we're going to have a look at ordering. And in the last lesson, we said we could order very easily when our denominators were all the same. That was super easy. So when the denominators were the same, then all we had to do was look at the numerator and we could order them, right? And when the denominators were different, but the numerator was all the same, then that was also quite easy because we could just look at the denominator and see which one is bigger and which one is smaller. So tell me, Shakira, yes, it is preparing you for a test, but Shakira, which is the smallest fraction of the blue ones on the screen? Which one is the smallest fraction? Is it a half or is it a 20th?
It's the half.
Is a half smaller than a 20th? So if we think, let's go back to our fraction wall. Okay. So if we have a look at the fraction wall, here's a half. Remember, our half was a nice, really big amount of cake or pizza. And a 20th, you have to split it up into 20 little pieces. So we've got the same amount of cake, but we've got to divide it into 20 pieces. So that would be 10 there. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a slice of a 20th. Which one's bigger? Which one do you get more cake? A half or a 20th? And I think the answer is a half. I know I would definitely like to get half a cake, not 1/20th of a cake, okay, or of a pizza. So a half is a bigger fraction because you get more of the cake or more of the pizza. Okay, so you get more of the amount than a 20th. So when we're ordering, it's really important to remember that the bigger the denominator, okay, so the bigger the denominator, the smaller the fraction. Okay, so the bigger denominator is the smaller fraction. Okay.
Mom, so it's the 20th.
So the 20th is the smallest one. So this is our smallest guy there. All right. Okay. Now, it's very easy when we have the same size denominators and numerators, but it's really hard when they're different sizes, right? So then how on earth are we making you crave for cake? So how on earth do we do it when we have different denominators? How do we compare? What do we do? Okay. Angel, what's your question?
Ma'am, at my school we did these finding the lowest common fractions and finding the highest common fractions. What we do is we go to the multiples of the decimals and see if there's a number that is the same as the other decimal.
Of the other denominator, 100%. Okay, so when the denominators are different and we need to compare, we need to find the lowest common multiple or the lowest common denominator. Okay, so to do that, what we do is we list the multiples of both of the denominators. Hang on one second. Keep that question or type it, and then I'll ask you now. Okay, so we're going to find the multiples. And remember, a multiple is the answer in the times table. Okay, so we list the multiples of each of them. And then we circle the lowest number in both lists, and that's going to be your new denominator. Okay, whatever you multiply the original denominator by, you're going to multiply the numerator by. Okay, so we're going to try one. Okay, so if we need to compare 3/4 to 8/12. Okay, so we have to compare 3/4 to 8/12. First we need to do is list the multiples of 4 and 12. So that's why we did this in the last section. And the multiples of 4 are 4, 8, 12, 16. I'm going to stop there. And the multiples of 12 are 12. Oh, is that in the other list as well? Yes, it is. So that becomes our lowest multiple because it's in both lists. And so that's going to become our denominator. Okay, so now we have 3. Oh, I don't know what's happened there with number 3. So what did we times the 4 by to get to 12? We times it by 3. And so because we times our denominator by 3, we have to times the numerator by 3. Because we times both of them by 3. And 3 times 3 is 9. And 12 is the first one. So we didn't have to times that by anything. So that just stays the same. So we have 9/12 plus 8/12. Can I compare them now? Well, it's not plus. Can I compare them?
Yes.
Yes, we can. And which one's bigger? Tara, which one's bigger? 9/12 or 8/12?
9/12.
9/12. There we go. And we can compare them and we get 9/12. Okay. So somebody wanted to say something or ask a question?
It's me, ma'am.
Okay, what did you want to ask?
Ma'am, when are we gonna start doing a ratio, cube, and a square root?
So after fractions, that's when the exponents are going to come in. So the square roots and the cube roots and squares and cubes will come in then. And ratio and rate we'll do at some point next term. Okay, we're going to run out of time this term because we started a bit later. Okay.
Yes, ma'am.
All right. So I'm going to give you some work to do for me to try these. Are you ready to do a little bit to try? Should I leave these? Okay, so I'm going to say times that by 3 and times this by 3. And that gave us 9/12. All right. So what I want you to do is compare for me 3. No, let's not do 3/4. We've already done 3/4. 7. Oh, wait, hold on. I've got some here. Here we go. Right. I forgot I made these. Right. So we're going to compare these. And I've given you the notes here that we did just on the other board. So we times that by 3 and we times that by 3. Okay. So what I want you to try and do for me is do A first. Okay. So do A quickly and then pop in the chat when you've finished it. So follow the steps. Do A and then we'll go through A and see how you do. Okay. You first have to find the lowest common multiple. That's your first step. Okay, so step 1, you find the multiples of both of your denominators. Step 2, that will become your lowest common multiple or the new denominator, lowest common denominator. Okay. Okay, Nicolene, you can talk us through A, please. Okay, what's our first step, Nicolene? Okay, Princess, can you charge your phone, my darling? Okay, Nicolene, do you want to unmute and tell us what to do?
Ma'am, Nicolene doesn't know how to speak English.
Nicolene, wil jy Afrikaans praat? Jy kan sê vir ons wat om te doen in Afrikaans as jy wil. Nicolene?
Ma'am, sugar na munch.
Okay, Nicolene's gone quiet. So I'm going to ask, let's ask Ashley. I haven't heard from Ashley today yet. Right, Ashley, what's my first step? Ashley, are you there? Oh, I can't hear anybody.
Can I answer it?
Okay, go. Answer it. Everyone's too quiet. Let's go.
Okay.
We're gonna waste a lot of time.
So first we're gonna times the 6 with the 12.
Why?
Because then the 2 and the 6 times table had the same number. It has the same number of 12.
Ah, stop right. Tell me the multiples of 6 quickly.
6, 12, 18, 24, 30, and 36. That's what
Okay, I'm going to stop there. Right, tell me the
Okay.
multiples of 2.
2, 4, 6, 8, 10, 12.
Stop. 2, 4, 6.
Yes.
Which number comes up first in both lists?
12.
Look again. Look at my board. What number did I write in both lists?
I can't see it.
6.
Didn't we start the 6 times table with 6?
Now I see it.
Do you see it?
Yes.
So 6 is my lowest number that I can find in both of the groups. Okay.
Okay.
So 6 is in both. So 6 is my denominator. Okay. And I didn't have to change this one because it's a 6. So I'm going to still have 5 over 6. Okay. And what do I need to multiply by 2 by to get 6?
3.
I times it by 3. So I have to times my numerator by 3. So I have to times my top number by 3. And 1 times 3 is?
3.
3. Now I can compare. Which one's bigger?
5 over 6.
5, 6 is bigger. Okay. So remember, when you're listing your multiples, the first multiple is the one of the number. Okay. So very often we can just use the multiple of the number, but very well done. Okay. You would have gotten the same answer by using a bigger multiple, but it's just going to take you longer. All right. Let's do B for me. Okay.
B. I haven't done it.
Okay, Lacey Butler, have you done B? Guys, can we move away from prime numbers in the chat? We're not there, we're on fractions. So let's focus on fractions for now and we can talk prime numbers next time. Okay? So leave prime numbers and prime factors and we'll get there another time. Let's focus on fractions, please. Right. Thank you. Right, what are my factors, Ethel, my multiples of 8? Ethel? No, Ethel. Is there anyone who'd like to talk me through this one? Makati's got his hand up. Okay, Makati, I think we're going to have to stop, sir, because we're running out of time, Teacher Coco.
Yeah, I think so.
So what I want you guys to do for me, please, is first off, okay, next lesson, we're going to focus, right? There's lots of people who are focusing, but if I look at the chat, there's lots of chat going on about other topics that aren't what we're dealing with, right? And like Teacher Coco says in the chat, if we carry on getting distracted in the chat, we're going to disable the chat function, all right? Because we're not learning about exponents and prime numbers and prime factors now, we're doing fractions. And then when I ask a question about fractions, there's no answers. So we're going to have to be a little bit more strict if people are going to play around too much, all right? Which I don't really want to do, but we do need to do this, all right? So what I would like you to do is, if you can, take a photo of the screen. Okay, take a photo of the screen or take a screenshot. And I want you to try these ones for me for Monday if you have a chance. And we're going to start with this on Monday. Okay, so the instructions are all here. And then we're going to keep going from here next week. All right, so take a photo of this and then we'll move on from there. Okay, if you have a question, you can stay on at the end, but I need to hand over to Teacher Coco. All right, Teacher Coco, over to you.